Students, this question was asked in IIT JEE Main 2022 from the chapter Units and Dimensions. Identify the pairs of quantities having same dimensions: velocity gradient and decay constant, Wien's constant and Stefan's constant, angular frequency and angular momentum, wave number and Avogadro's number. Okay, students? So we have to first check the dimensional formula for the 8 physical quantities given here. Let us begin. What is velocity gradient, student? Velocity gradient is dv by dx. And what will be the dimensional formula for dv by dx, student? dv is also a velocity, so it will have dimensions lt to the power minus 1 and dx will have dimensions l. So students, this l and l will cancel out. It will have dimensions t to the power minus 1. What is decay constant, student? We know about decay constant from radioactive decay law. This law states that, student, the rate of nuclear decay is independent of time, and the time rate of decay is directly proportional to the existing number of radioactive atoms, students. In mathematical way, that is expressed as dN by dt is directly proportional to minus n, or this is written as dN by dt is equal to minus lambda n, where this lambda is, student, the decay constant. So what will be the dimensions of lambda, student? From this we get the formula lambda is equal to dN by dt by m. Okay, student. Then what is dN? That is also m, and number of small number of radioactive atoms, and this is dt will have time. So student, this is a number. So this is m0, l0, t0 divided by p, and this is simply m0, l0, t0, because this is also a pure number. So this is 1 by t, and thus t to the power minus 1. So we can see velocity gradient, decay constant have the same dimensions. Okay, students? So option A is correct. Next, let us verify the other three options, students. In option B, the first physical quantity given is Wien's constant. Wien's constant can be learned from, student, Wien's displacement law. Displacement law. This law states that the peak of a wavelength of radioactive emission is inversely proportional to the temperature of the black body. Okay, student? If these are the curves, okay, if these are the curves at different temperature, the peak, this peak, lambda, this that is called lambda n, is inversely proportional to the temperature of the black body, or lambda n is equal to b by t, where b is called the Wien's constant. Okay, student? So b is equal to lambda n by t. Its SI unit is meter, degree Kelvin, and what will be its dimensions? Dimensions of B will be equal to lambda is a wavelength, and you know wavelength means a distance, so the dimension will be L, and that of temperature is Kelvin. So this becomes Lk. Okay, students? And what is Stefan's constant? Stefan's constant can be known from Stefan law, which is also known as Stefan-Boltzmann law. Okay, student? Then what is Stefan-Boltzmann law or Stefan law? Stefan's law of black body radiation states that, student, the rate of energy emitted by a black body per unit area per unit time, that is called m. M is equal to E divided by A divided by T, or we may write this E A T. The rate of energy radiated by a black body or, or unit surface area or unit time. This M is directly proportional to student the fourth power of the absolute temperature of the black body. This is Stefan law, and this M can be written as sigma T4, where sigma is the proportionally constant student, that is known as the Stefan's constant. Then what will be the formula for sigma student? Sigma will be equal to M by T4, and what is M? M is E by A T by T4. Okay student, what is the dimensional formula? Then dimensional formula of sigma will be dimensions of E by T by T4. Then what is the dimensions of energy student? You know every forms of energy has dimensions ml2 T minus 2. This is area, so dimensions is L2, and that of time is T. Okay student, and this is 1 by K4. We write the temperature as K degree Kelvin. In dimensional formula we write it K. So students, this L2 gets cancelled. This becomes m T to the power minus 3 and K to the power minus 4. This is the dimensions of Stefan's constant. And what will be its SI unit student? You can watch from here. The SI unit sigma will be equal to E by A T by T4. So this will be equal to this E by T, the energy emitted per unit time, that is the power of the black body, which can be written in the forms of SI unit is what? You know student, SI unit of power is what? Watt per meter square Kelvin to the power 4. Okay student, this is the SI units, and this is the dimensional formula for sigma Stefan's constant, and this is the dimensional formula for Wien's constant. So we see both of them are different and they are not the same. So option B is not correct according to the question. Next, let us examine option C. What is angular frequency student? We know frequency in linear motion. Frequency is the 1 by T, but T is the time period of oscillation or vibration. So frequency is the numbers of oscillations or vibrations per unit time. And what is angular frequency student? Angular frequency is denoted by omega, and the formula is twice pi by T. So what will be the dimensions of angular frequency student? That will be the dimensions of twice pi upon dimensions of T. Twice pi is a pure number, so it is dimensionless. M0, L0, T0 divided by T, so this is T minus 1. Okay student, and what is the dimensions of angular momentum? Angular momentum, so let us write here angular frequency omega as dimensions T to the power minus 1. Then let us check the dimensions of angular momentum. Okay student, angular momentum is denoted by L, and the formula is mvr, where m is the mass of the body, v is velocity, and r is the radius of the circle in which it executes circular motion. So dimensions of L will be dimensions of mass, dimensions of velocity, and dimensions of radius multiplied together. So this becomes capital M in square brackets. Velocity, you know student, Lt minus 1, and that of radius is length L. So this becomes M L2 T minus 1 is the dimensional formula for angular momentum, which differs from that of angular frequency. So option C is also not correct according to our question. Let us examine option D. What is wave number student? Wave number is denoted by K, and this is 1 by lambda, means the number of wavelengths per unit length or unit distance is called the number of waves, or unit distance is called the wave number, student, 1 by lambda. And you know this is a distance, so the dimensions will be equal to dimensions of 1 by lambda, that is L to the power minus 1, students. And what is Avogadro's number? It is a pure number, you know, the number of atoms in 22.4 liters at STP, and that is N is equal to 6.023 into 10 to the power 23. This is a pure number, so it is dimensionless, or the dimensions n0, n0, t0. Okay, students. So their dimensions also differ. So the correct answer is option A, students.